First, can you hear me? Anyway, just how can you ensure the accuracy of the delta? Because there are several factors such as the wind speed, the temperature, etc. Those can affect the delta. So how can you ensure that?
Also, I want to ask, like Alan, he said that how you be about the accuracy of data. I want to if you could elaborate on the instruments used for differentiating between transboundary pollution and local pollution.
And my question is what's your stories behind going to work at NASA? How did you form your career and what's the motives? Yeah, you can be brief on all three of them. Thank you.
Thank you so much for all the questions. These are great. Dr. Becky or Dr. Kristen, do you want to take on one or all three of the questions?
I can maybe start with the first question and then pass it on to you guys for the other ones. But so I think the question was about how do we know that our measurements are accurate when we're up in the air and there's a lot of different variables. So for ours, I think there's two things. One is calibrating our instrument in the lab. So showing it some kind of known quantity in the lab and making sure that that's what it reads out, or making adjustments to make sure that's what it reads out. But I've also been on flight campaigns where we'll do in-flight calibrations. So for example, we might have a tank of, let's say another campaign, I was measuring carbon monoxide. We would have a tank of carbon monoxide on the plane that every now and then we would pump some out into the instrument, and we knew the concentration of this carbon monoxide, so then we would make sure that at altitude and in the wind and in the cold and all those factors, that it was still reading the same amount, and if it wasn't, then we would know after it landed that we had to make adjustments and kind of come up with a calibration plan to make sure that it read the correct the correct concentration of the air quality.
So similarly, our instrument, we do a lot of in-flight calibrations, and we calibrate our instrument in the lab before and after. And another way that we ensure that we have good data quality is that we compare a lot of the instruments measure the same thing on the plane. So we measure VOCs, and there's two other instruments on board that measure a lot of the same VOCs. So we compare our data and make sure that they are in good agreement. And if they're not, then we have to look more carefully at our calibrations. So for I can't remember, I think it was the second question talking about transboundary, how do we know where the air is coming from? That's a great question. There's a couple different ways that we can do that. One of them is that we have really good forecasting, and then we sort of run our forecast models backwards so that we can see where the air came from. So we know what we're expecting to see, and then we also check afterwards with the data that we have from measurements to know and to better qualify where air came from. And the other thing that we can do, like Dr. Brennan was saying, a lot of gases in a lot of regions have fingerprints so that we can see where that air came from. We can look at the concentrations of different gases and actually identify locations and regions that influence that kind of air. So I hope that answers that question. The last question I love, I think it's a great question. I have been doing this research, this kind of work for almost 20 years now. And I started off wanting to be a chemistry high school teacher. And I went through university and I had my degree and I almost became a chemistry high school teacher. But I got asked if I wanted to stay and do grad school, and I was really excited about that because it was, I really liked learning and I really liked being able to know more about the planet. And I did an atmospheric chemistry PhD, and that is what really pulled me in and made me excited about this field. And there's a certain importance and relevance. It affects people and it affects people's lives, how air is moved around and how it's polluted, and that's probably the thing that I most enjoyed. And a lot of it was just, I don't know, being in the right place at the right time and having a really good opportunity to do this kind of work. So what about Dr. Kristen? Do you want to answer that last question too?
Yeah, totally. That's a really good question. Similar to Dr. Becky, I think there was a lot of just right place, right time for me as well. Even as a kid, I kind of always knew that I wanted to do some kind of environmental work. I always really cared a lot about that. But when I kind of got to the age where I was going off to college. Like, there's just so many different aspects of, you know, Earth and the environment that I had absolutely no idea, like, what specific thing within that I wanted to do. But then I kind of got lucky enough, I ended up doing an internship with the US Department of Energy, where they just kind of randomly assigned me to an air quality related project. And I started doing it, and was like, oh my gosh, this is so cool, like I need to keep doing this. So then I went on to go to grad school and then continue working in this field. But yeah, kind of similar to what Dr. Becky said. I think it could have gone a lot of different ways had just some other other experiences or opportunities came up. But this is kind of where the opportunity lay, and I love doing it. So it's been really awesome to keep working in this field since then. What about you, Dr. Brenna?
Thank you for asking. I feel like the first two questions have been answered, so I'll skip those. But the third one, I think we all love the third one because we all love talking about atmospheric science and airborne science. For me, I was just drawn to the fact that a lot of the air is only the way it is for a brief moment, and then either the wind changes it, the pollution changes it, something will change about it. Even me moving my hands like this is changing where the air is located around me. And I think that is so beautiful. Like, I think that the idea that everything is the way it is for just a snapshot in time, I think that that's fascinating, and I'm really drawn to that idea of these simple snapshots around us. And so I love the idea of categorizing and understanding these snapshots better, whether it's pollution, whether it's air quality, whatever it is. I really am drawn to that idea. So for me, that's what allowed me to pursue a PhD in atmospheric chemistry, is just this idea that nothing looks the way it does right now, and then even now it's different than it just was. I think that's very cool. So that's me. Thank you so much for that question.
So